This is your presenter Asloob Mudassar, and I am presenting slide number 7 of the course on laser physics. Question 7. Considering a two-level laser system, write down the equation describing the change of flux in the incident plane wave when it passes through an active medium with population inversion achieved. Answer. Let N1 is the population of level 1, that is the particles per unit volume at time t, and N2 is the population of level 2. Under normal conditions, N1 is always greater than N2, but under suitable pumping process, the population inversion can be achieved between the two laser levels. The condition given in the question is N2 is greater than N1. So it means that we have achieved the population inversion in this case, and F is the photon flux of the plane wave incident on an active medium of width dz. When the plane wave will pass through the active medium, the decay rate of a population in level 2 will be greater than the absorption rate of the population in level 1. That is, at any instant more photons are added to the system due to stimulated process than the number of photons subtracted from the system due to absorption process, because the population in the level N2 is greater than the population in the level N1. That's why we have said this statement. Now let delta F is the change in flux over the length of the active medium as depicted in the figure question 8.7.1. We can write. So let me show you first the figure. This is the figure. The caption is plane waves of photon flux F passing through an active medium. So you can see that we have an active medium. The width, the length of the medium is dz, and photon and plane wave with photon flux F is incident on the active medium, and it passes through, and then at the end we have a photon, which we have a flux which is F plus delta F, and you know that in this case we have to calculate delta F, that is the change in flux of the photon. Okay, so we can write equation number 7.1 as dF is equal to, that is the change in flux, is equal to W21 into N2. This term is due to stimulated emission, minus W12 into N1. This is due to stimulated absorption. So since stimulated emission is greater than the stimulated absorption in this case, so that's why we have written this term, and we have subtracted the absorption term from the stimulated term. And then we have in the next step we have replaced W21 by sigma 21 into F, and we have replaced W12 by sigma 12 into F. So rearranging these terms, the last term becomes dF is equal to F times, within the parenthesis we have sigma 21 into N2 minus sigma 12 into N1, and at the end we have multiplied by dz, which is the length of the medium, of the active medium. If the level 1 and level 2 are G1 and G2 folds degenerate, then equation 7.1 takes the following form as given in 7.2. So you see that here we are talking about the degeneracy, that is the level 2 is G2 times generate, and the level 1 is G1 times degenerate. So we can say, so what we have to do is that we have to, in equation number 7.1, we have to replace, for example, sigma 12 by G2 over G1 into sigma 21. So making this substitution, replacing sigma 12 by G2 divided by G1 into sigma 21, and then taking the common terms outside the parenthesis, we can write equation 7.2 when the degeneracies are present. That is, the level 2 is G2 times generate, and the level 1 is G1 times degenerate. Then the flux, then the change in flux can be written as given by equation 7.2. In the derivation of equation 7.1 and 7.2, only stimulated emission and stimulated absorption were considered, because during the lasing process, the spontaneous and the non-radiative decay processes have relatively negligible contributions. Moreover, the photons due to spontaneous emission travel in random directions with negligibly small number traveling along the cavity axis. So you see that this is 7.1 is our answer when we have non-degeneracy, when we have no degeneracy present. That is only one level is present in the level 2 and only one level is present in level 1. So when degeneracy is present, that is there are G2 levels in level 2 and there are G1 levels in level 1, then it means that the level G1 and G2 are it means that the level 1 and level 2 are G1 and G2 folds degenerate, and in that case we can write equation 7.2. So 7.2 is our answer when the degeneracy is present, and 7.1 is our answer when no degeneracy is present. So this is the end of slide number 7.